All right, question 8. If a jet traveling at 45 meters per second takes 5 seconds to stop, what is the plane's acceleration? So this is a velocity. This is a time. We're looking for the acceleration. Stop is how fast. That's 0. So if I'm going initially 45 meters per second, and then I stop to 0 in 5 seconds, how do I find acceleration? Acceleration equals v2 minus v1 divided by t. So that's going to be v2 equals 0, v1 equals 45, t equals 5. So we have 0 minus 45 divided by 5, and that is going to give us negative 9 meters per second squared. And the negative, remember, that means that you're slowing down, you're decreasing speed. So a sky jumper dives from a plane after 12 seconds. How fast will he be falling? So I have to draw my picture. So let's get my plane. Oops. So there's my plane, and I'm going to jump out of the plane and skydive after 12 seconds. How fast will I be falling? So how fast am I going before I jump? I'm going, before I jump, 0 meters per second. And I need to know how fast I'm falling afterwards. So again, we're going to be using gravity. And I'm looking for a speed. This is asking me for a velocity, so I'm going to use this formula. v2 equals v1 plus acceleration times time. And this one is not one that we've used a lot. My acceleration is going to be the acceleration due to gravity. So what is gravity? That is 9.8 meters per second squared. And it's actually going to be negative because we're going towards the ground. So v2 equals v1, 0, plus negative 9.8 times 12. And when you multiply that out, it's going to give you v2 equals negative 117.6 meters per second. So that's going to be like in sig figs, 2 sig figs, it's going to give you negative 120 meters per second, or just negative 118 if you just want to round. So how far has he fallen? So again, we're going to use this number to calculate. So how far has he fallen? We're going to actually not have to use the final velocity because if I'm just finding how far he's fallen, I'm going to use the formula distance equals 1/2 acceleration times time squared. So at this point, my time equals 12. My acceleration is the acceleration due to gravity, which is negative 9.8 meters per second squared. And so I'm going to go ahead and plug in d equals 1/2. Got to put that in parentheses in your calculator or you'll get the wrong answer. Negative 9.8 times 12 squared. 12 squared is 144 times negative 9.8 times 1/2. And that's going to give you 705.6 meters. So 706 meters. And that is the answer to number 9. Number 10. What is the distance a penny will have traveled after 12 seconds of free fall? So if I'm standing here and I drop a penny, and I'm going to draw a hand, 1, 2, 3, 4, 5. I'm going to drop a penny. So the penny is going to fall for 12 seconds. Okay, so time equals 12 seconds. And what's the only thing affecting it? That's going to be gravity, because we're going to ignore air resistance. So gravity is 9.8 meters per second squared. That's going to be an acceleration. So again, I'm solving for a distance. So we're going to use the same formula. D equals 1/2 AT squared. This should look really familiar to you. Distance equals 1/2 times A, negative 9.8, because again, negative, because I'm falling towards the ground. and times t, which is 12, again, squared. Look at that. That's the exact same math we just had. So we know the answer to that one because we just typed that into the calculator. D is going to equal 705.6 meters, or 706 meters. And it's technically going to be negative because it's 706 meters down. That's the displacement. It's going towards the ground. Emily drives her red Ferrari at 30 meters per second. That's a velocity. When a dog runs out in front of her car, she slams on her brake and stops. That's a velocity, which equals 0 in 3 seconds. That's the time. Missing the dog. Yay! What was her acceleration? Acceleration. So I'm using A equals V2 minus V1 divided by T. This is going to be my initial velocity right here, V1 is 30. This is going to be V2, stop. So I've got V1 equals 30, V2 equals 0, so and T equals 3. So I have 0 minus 30 divided by 3, which is going to equal negative 30 over 3, which equals negative 10 meters per second. And this is a squared. So meters per second squared. So this is a deceleration of negative 12 meters per second squared. That's how fast you have to brake in order to not hit the dog. And moving on to number 12. Charlie Chapman throws his top hat straight up into the air at 8.7 meters per second. How long will it take to return to his hand? And this is going to be, you're going to have this as a bonus question or something very similar as a bonus question on the test. So let's say that I'm standing here, Charlie Chaplin's standing here, right? And you toss your hat up into the air. Now the hat's going to go all the way up into the air, and then eventually it's going to get to a point where it can't go any higher and it's going to stop, right? So the hat stops traveling there. And then what's the hat going to do? It's going to fall back down. And I'm drawing it in a parabola, but you know, it would fall back down to Charlie and it would be even, not all jacked up like that is. So if when it leaves his hand, it's going at 8.7 meters per second, and at the top it's going 0 because it's stopped, right? V2 equals 0. V1 equals 8.7. And I want to find the time here. Now, the time is going to be the time that it goes up and then the time that it comes back. So the first thing I need to do is I actually need to find out kind of what equation I'm going to use. I've got time, I've got two velocities. The only equation I have really that has two velocities and times is V2 minus V1 over time. Okay, so that means I have two velocities, but I need an acceleration. So what is the acceleration that is affecting this? So as you throw the hat up into the air, it's slowing down. Why is it slowing down? Because of gravity. So my acceleration is really going to be the slowing down due to gravity. So what's the acceleration? Acceleration equals negative 9.8 meters per second squared because, again, it's gravity. So we're going to plug that in. Negative 9.8 equals V2, 0, minus V1, 8.7, divided by T. So I'm going to have negative 9.8 T equals negative 8.7. Divide both sides by negative 9.8. And then my negatives are going to cancel, right? So I'm going to have just 8.7 divided by 9.8. And that's actually going to equal T equals 0.888. But that's how long this takes, right? And that's also how long this takes, because however long it takes to go up, that's how long it takes to go back. So really, I need to add these two together or multiply 0.888 times 2, and that's going to give me the total time equals 1.8 seconds. It's actually 1.78 seconds, 1.78. When you add those together, you get that. But the total time is going to be 1.8 seconds. And that is very tricky, and that's why it's a bonus on the test. Next question, number 13. A boy walks a total distance of 110 meters. His starting position was at 20 meters and his final position was at 34 meters. If it takes him 75 seconds, what is his speed? So the formula for speed equals distance divided by time. What's his total distance? This is my total distance. So that's 110 meters divided by my time. What's my time? That's my time, 75 seconds divided by 75 seconds. And so that is going to give me a very simple answer of 1.5 meters per second. That part was very easy. This asks for its velocity. Remember, velocity is going to be displacement because it's asking for average. It doesn't say average, but it's asking for average. Displacement divided by time. So my displacement is how far am I from the starting position. So if I started at 20 and I ended up at 34 meters, it doesn't matter how far I walked, right? How far am I from the starting position? And the answer is I'm 14 meters from the starting position. Divided by my time. My time's still 75. So 75 seconds. And that's going to give you 14 divided by 75 equals 0.186 meters per second. And when you do the sig figs on that, that's 0.19 meters per second. 2 sig figs. Number 14. Okay, this is a graph. It's pretty tricky. So we have to break it down. So the first thing we need to look at is this is meters versus minutes. So this is just telling me my distance, okay? What is the person's displacement from 0 to 10 minutes? So from here, 0 minutes to 10 minutes, how far had I walked? So you look over and I've gone 200 meters. That's pretty easy. What is the person's displacement from 10 minutes here to 20 minutes here? So that's saying how far did I walk to go from here to here? This is 700 meters. So to go from 200 meters to 700 meters, I went a total of 700 minus 200. That's going to give me 500 meters. I hope everybody sees that. And how fast is the person traveling during that 10 to 20 minutes? So here I went 500 meters, and I did that in 10 minutes, right? So that's 500 meters in 10 minutes. That's going to give you 50 meters per minute. Okay, and then how fast was the person traveling from 30, that's here, to 35? So between 30 and 35, I was at 800 meters, right here, 800 meters, and at 35, I'm still at 800 meters. So how fast was I traveling? Let's see, I was at 800 meters. I'm still at 800 meters. Sure sounds like I'm stopped right there. So I was traveling at 0 meters per second there.